So from block function we know that the wave function associated with an electron inside a solid can be given by this equation, where ux is a periodic function. So ux can be written as ux plus a ux plus twice a u x plus n a. Okay. So what is a? A is actually the our lattice constant, right? This is lattice. Okay. So if this is the whole crystal, right, and its length is L, so this is A. So how many are there? So if there are 1, 2, 3, 4, 5, okay, so 5A will be equal to L. That means the 5 will be number of unit cell, right? 5 is the number of unit cell. So number of unit cell into the distance of one unit cell will be equal to the length of that crystal, right? Therefore we can write ux will be equal to ux plus L, right? Because now we consider that the crystal have n numbers of unit cells, right? Therefore n into a equal to L. This is just example, right? Yeah. So that's what we find out. Now, so now, okay. So what we did in block function, we also can do here. So psi x plus L will be equal to e to the power I k x plus L into u x plus L, right? Therefore it will be e to the power I k x plus e to the plus I k L into u x plus L. This can be written as e I to the power k x into e to the power I k L e to the power x plus L. Again, e to the power x plus L is equal to ux, right? Therefore we can write psi x plus L is equal to I k L into u x into e to the power either I k x into ux. So we replace this one by ux. Okay, that should be equal to e to the power I k L into psi x, right? Since psi x is equal to e to the power I k x into e to the power x, right? Yeah. So let's give this one a name, question 1. Okay, so again Bloch's theorem suggests that, right? So we know that psi x plus L is equal to psi x, because x is a integral multiple of a, right? That's why it will be happening, and we have already proved it in Bloch function. Okay, so now therefore psi x plus L, that is equal to psi x is equal to e to the power I k L into psi x, right? Therefore e to the power I k L must be equal to 1, right? So when it will be 1, e to the power I kl is equal to, so it should be cos cos twice pi, cos 0 is equal to 1, cos 0 equal to 0, yeah, okay. So let's do it like this, that kl plus I sine kl, right, e to the power I theta, this is the formula, e to the power I theta equal to cos theta plus I sin theta. Yeah, this is the formula, right? So this is equal to 1, right? That's 1 plus I kl is equal to, this is equal to 1. When it will be 1? If cos, this one is this one will be 90 twice pi, so it should be cos 0 is equal to 1 plus this is sin 0, then this will become 0, this will become 1, so finally it will become 1, right? Therefore we can write e to the power I kl, also this we can write as twice pi, because twice pi and 0 is the same, plus I sin twice pi, right, which is equal to cos of kl plus I sin of kl. Therefore kl is equal to twice pi, right? Therefore kl is equal to twice pi. Or we can write any integer, that is kl is equal to twice n pi, right? Because you can multiply any number n here, or if you want you can write this one twice n pi plus I sin twice n pi is equal to cos kl plus I sin kl, right? This is what we get, okay, where n equal to plus minus 1 plus minus 2 dot 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 dot. Okay, so this n is the integer number, and previously we considered one n, that n is the number of integers, so these are two different. So let's say yeah anyway, so maybe that's okay. So therefore k is equal to twice n pi by l, right? We find one of these ones, so let's give this number 2. Okay, yeah, so what we get is that k equal to twice n pi by l, yeah, that implies n will be equal to kl by twice pi, right? So if we integrate with respect to k, if we differentiate with respect to k, then by del k l by twice pi into k, right? Or you can write del n is equal to, so dk by dk is equal to l by twice pi, that implies dn is equal to l by twice pi dk, right? So this one will be equation 3, right? So the number of possible function in the range dk is given by this one, right? Therefore dn is the number of possible wave function within the range dk. So now, do you remember in the diagram in the previous video like this one is in x-axis is k, right? These are the values of k. So this one is plus pi by a, this is a k, this is also minus pi by a. So what is dk? Dk means any small range here. Now we need to integrate from here to here. It's 1 billion, so we'll get the number of possible wave functions in one band. Therefore, the number of possible wave function in the range plus pi by a to minus pi by a is, so n will be equal to integration of delta n is equal to L by twice pi dk, so pi by a, or you can say minus pi by a to plus pi by a. So we can write this one as like this. Okay. Therefore, n is equal to L by twice pi, because L is constant, so it is minus pi by a to plus pi by a to dk, which will be equal to L by twice pi. So integration of dk is k minus pi by a to pi by a, that will be equal to L by twice pi. So pi by a minus, again minus, so it will be plus pi by a double minus, so it will be L into L by twice pi, so it is twice pi by a, right? So twice pi will go, so it will be L by a. So this is our final result, okay, which is the number of possible wave function in a band.